Hi, so you've basically seen this setup before. It's an light sensor, and when I cover it up, it allows me to either close or open the panels that I created in Grasshopper. Um, you can see me covering up and opening up. But now I've created an override, which if I turn it on, then it basically kills the light sensor output, and it allows me to manually control whether the panels open or close. Alright, now I'm gonna show you how to set this thing up. First thing that changed, you probably noticed, is that I've added a toggle button to the TouchOSC. So let's open up a TouchOSC editor. Let's change it to a horizontal iPad. I can either build it from I'll just build it from scratch. If you right click and get a label, and increase the text to, let's say, 40, and say I just wrote servo control panel, but it can be Grasshopper control panel. Just name it whatever you usually name it. Just give it an outline. Next we will need a rotary. Let's make it bigger. If you click on it, you can call it servo, or you can call it whatever else. I'm calling it servo just because in processing, when you're coding, the name actually does matter. For this particular one, when we're using Firefly, it doesn't matter what it's called. Firefly is going to be able to read it anyways. So this is actually, it can actually be called whatever. Panel slider. We're going to keep it red. The range needs to be changed to 180. No rollover. So alright, that's good. Now we need a toggle button. And if you click on it, it toggles from 0 to 1. Keep the auto checked, and you can just keep the name toggle. And I just added a few more, I just added a couple more labels. I gave them an outline and call them, you can call them panel control. Change the fonts to 40, so it's just bigger. And this one is an on off button. Change the outline font. It's not perfect, and it's not exactly what I've had. It's just graphics. Alright, so this is the basic layout. What really matters is that the rotary control has the range set up from 0 to 180, and then the value range for the toggle button is 0 to 1. Once we have that set up, just hit sync. And if you watch my previous video, I explain exactly how to upload those layouts to an iPad. So if you need to set up your iPad to receive new layouts from TouchOSC, just watch my previous video. So if you go to my website at arculab.net, under blog 2012, first video that should be up there. Actually, it's going to be a second. It's called Arduino TouchOSC Control Servo, and it has the first layout that I've made for it explained, and there's actually a video. So if you hit tutorial,
so what you see on the screen,
there'll be a video on YouTube that I've uploaded that you can follow to figure out how to upload the layouts to iPad. Okay, let's get that out of there. So once we have that, I'm just gonna quit. I'm not gonna save it. I have my layout saved up and loaded up. Next thing we want to do is open up Arduino IDE, and all we need is a Firefly Fermata. You can download that from the website. That's actually right here, the www.fireflyexperiments.com. That basically allows Firefly and Grasshopper to communicate with your Arduino. So you want to upload that sketch to your Arduino. It's actually spitting out an error just because my Grasshopper is using Firefly as we speak. I mean, it's using Arduino as we speak, so I was clogging up the port. So once you upload it, you can go ahead and close Arduino IDE, and the only thing left is to set up the sketch for our panel. And I'm using two star-shaped panels. I mean, 4 star-shaped panels, but it can be anything. It can be a rectangle. The only thing that matters is that at the end of the sketch there is a number, a range from 0 to 1. That's an output, and you can plug it in and control anything. Once we upload the sketch to Arduino, let me show you something. We're actually using an LDR sensor. So here is a fritzing diagram how to hook up your LDR sensor, and you want to plug your LDR sensor data cable into analog in, and then the plus and minus goes into a 5 volt and a ground, and you need a resistor in between those. So this is a basic sketch. It's very simple. If you have any Arduino experience, you should be able to hook it up. So that's the Arduino setup. We have the TouchOSC setup, and all we need is a Grasshopper setup. So let's open up our Grasshopper, and so I'm gonna start a new sketch, and I'm gonna go through it step by step. So basically we need a OSC listener, and it's if you watch my previous video, this time it's we're setting it up a bit different. So the OSC listener as inputs, it need a port number, and I'm still using port number 9, and I just got an error just because. Okay. So we're using port 9, and I need a toggle button. And previously I told you to set it to true, but now I want to keep it at false. And also you need a timer. And if you right click on the timer, I want you to set it to 1 millisecond. The reason why I want to keep it as false is because if you drop in a panel, and assuming that you have your sketch open, your layout open on iPad, if you toggle any of the data, it should be bringing them up. As we see previously, if you had it set to true, it basically resets that. But if it's set to false, if you toggle the button first on and off, and then spin the rotary on your iPad, you will see that another branch was created. So it basically created a tree branch. But if you set this to false, it doesn't matter if you toggle it or if you spin the rotary control, it's always one branch, just because the data tree gets reset every time. So we actually want to set it to true, false, and you want to toggle the rotary first, and then spin the servo. And in this case, it actually does matter which ones are in order, just because I'm extracting some data from it. So you want to have the toggle. You want to toggle it first, and then move the servo control, the rotary controller, so that it's a second branch of the data tree. So once we have that, I'm actually gonna call them out as items. Actually, I need a data tree item. Tree item. Copy and paste. We'll need 2 of them. So let's plug those in. I will need a number 1 and number 0 sliders. And what's gonna happen is that I'm calling out them out separately from a data tree. So basically, this item calls out a P stands for path, so it's gonna call out a servo. So it's 1, and then item 1, which calls out this this number out of the tree, and then this one calls out path 0, which is the toggle, and then item 1's plugged in, so it calls out number 1. So it just reads whether the toggle is 0 or 1, and this one reads the value once the toggle is set to 0. So next we want to bring in, if you go to math, boolean XOR, plug that in, and bring in slider 1, and plug that in. Basically checks whether the output from the toggle is 0 or 1, and that's going to control our dispatch. But before that, we actually need a Arduino. So that's basically gonna say whether to read data from the LDR sensor, or if the toggle is on, then it stops reading data from LDR sensor and it uses output from our iPad rotary control. But to do that, we're gonna need an Arduino Uno read. We need another timer for that one, and we need another toggle. So you want to toggle it through. You want to set your timer to 1 millisecond. You also need port 9 to get the Uno working. And we also actually need to open up Arduino Uno, so it's actually a port, and we need a toggle set to true to open it. So this opens up our Arduino, and this tells it to read data from the LDR. And the LDR was plugged in into analog pin 0. So output from this, let's get a panel, see if we're actually getting anything. This probably is a null. We're getting nothing right now. Actually forgot to check this on. Let's toggle that on. Once it's true, so these are outputs from your LDR sensor, and those are plugged into the dispatch. So what happens is this gate boolean component checks whether the toggle is on or off. So if the toggle is off, it checks against 1, so it's whether 0 or 1, checks against that and puts it into a dispatch, and dispatch filters data from the pin. So it either takes, if it comes through as false, it will dump the LDR sensor data into this data tree. If the output is, if the toggle is checked on, it gets true, it will dump it into this tree. Basically, we're gonna either use the LDR sensor or not. It kind of kills it or keeps it running. So what we need to do is get an integer and a remap number, and we want to be able to remap our numbers, just because the streams that come through LDR sensor are values ranging from 0 to 1023, I believe, and streams that are coming from our server was set up between 0 and 180. So we need to remap those numbers to be anywhere from 0 to 1. And actually, I didn't want my panel to collapse entirely, and so I'm going to set it to 0.2. But that's just the way my panels are set up in Grasshopper. So if you copy and paste that, just connect this. This should have it set up from 0.2 to 1. So like I said, the dispatch, not the dispatch, but the LDR sensor output are from, so if you click on the S and set the domain to be 1023, because this is the upper value of the light sensor, and this was going to be a remap for our servo, the toggle controller from TouchOSC, and this is set up from 0 to 180, like I've mentioned before. So basically, if we grab another integer, plug that in, so this is going to be going, actually I already have an integer, so let's plug that into our remap. So here are our remaps set up. Now we need to merge those two data streams. And let's call out an output as a 0. The reason why I'm doing that is, as you've noticed, the way I've set this thing up with the dispatch, it either has an output or it doesn't have an output. When it goes into B, then this branch will just be dead. So when we're merging those two, there's actually going to be just one value on there, or two values, but I always wanna pick up the first value that comes through. So if I uncheck it, so basically, yeah, if I check it, it kills one of the branches, and my data tree from the merge is just one item, and it's the 0. These are the inputs. If you can see that I'm actually toggling it on the iPad. But if I turn it off on the iPad, I get two items, just because output from the LDR sensor comes through, and since it's the first, I set it up as an input 1 on my merge, then it becomes the first item on the list. So if I'm calling out item 0, it will actually be just the LDR sensor. So that's how my on and off toggle works. So this is basically it. So this is your output, on and off. It works on iPad Touch, and you can plug that into whatever you really want to plug it into. I use my star-shaped panel, but we can use it. We can use anything. We go to Surface, and create a cylinder. Cylinder has a base plane, a radius. So if we type in 12, it'll give the cylinder a radius, and we can use the outputs to control the length of it. Oh, that cylinder to be smaller. I'm basically controlling the length, but since it's the way I've set it up, it actually rematched the numbers from 0 to 1. But you see the applications that you can actually use it for. Alright, thanks for watching, and feel free to visit my blog at Arculab. I'm pretty much posting all the stuff that I've ever done any experiments with Arduino or any other software to my blog. So visit that, or follow me on Twitter. On Twitter it's Arc Laboratory. So follow me on Twitter, and you'll get all the new tutorials. Alright, thanks.